C34 Jan 2014, question 11. The curve, we've got these parametric equations, trigonometric ones in terms of t, gives me the t range here. Point A with coordinates 5, 3 lies on C, we're going to find the value of t, we're going to get a normal and find where this normal cuts the curve again. Right, so I can do either do this equals 5 or this equals 3. This equals 5 actually gives you two solutions. This one just gives you one though. So I'll do 6 sine t equals 3, giving me that sine t equals 0.5. So the t must be pi over 6. There's only one value between pi over 2 and minus pi over 2. If you did this one, you could have plus or minus, but it must be this one for the y value to be 3. We want the equation of the normal, so we need the gradient. So the divide by dx, 6 sine t differentiated 6 cos t, 10 cos 2t is minus 20 sine 2t. Putting the value t is pi over 6 in, I'll have 6 cos pi over 6 of minus 20 sine pi over 3. I could have simplified this a bit with the double angle formula, but it turns out cos of pi over 6 and sine pi over 3 are both the same, so they'll cancel out. So it simplifies down to 6 over minus 20 or minus 3 over 10. The normal then is going to have gradient 10 over 3. So y minus the y value is 10 over 3, x minus the x value, using the 5 and the 3, multiply by 3 and take off that 9, add that 9 you get here. You get 3y equals 10x minus 41. Then it says the normal to C cuts the C against point B. Find the exact coordinates. So I'm going to use the parametrics in my equation of the line. So replace the y with 6 sine t. So 3y is 18 sine t. The 10x will be 100 cos 2t. I've got the minus 41. Now I'm going to solve this. I need to use a double angle formula with cos, because I can change this put it in terms of sine t. Cos 2t is same as 1 minus 2 sine squared. I've now got a quadratic in sine t, so I'll multiply this out, get it all on one side. I have 200 sine squared t, 18 sine t minus 59 equals 0. Now I know one solution is when sine t is equal to a half, because that's the point A. So I know that 2 sine t minus 1 must be a factor. Let's say that's the point A. Where 6 sine t is equal to 3. So the other factor then, 2 sine t multiplied by 100 sine t, give you the sines 200 sine squared. I've got minus 59 here. That's going to be minus 1 times whatever this is. So that must be plus 59. And this is the point B. So sine t at the point B is minus 59 over 100. Your calculator should get that if you stick that in the quadratic function. But we want the exact coordinates of B. So at B, we can put x equals 10 cos 2t and stick in our double angle formula as well, because we know what sine t is. We don't know what cos 2t is though, but we can change it using the double angle formula. So if we do 10 lots of 1 minus 2 lots of this. Actually, your calculator will work this out. If you did 10 cos of 2 sine at the minus 1, because t is sine at the minus 1 of minus 0.59, we want 2 lots of that, and the cos of that multiplied by 10, and it does give you that exact value. And then the y coordinate, 6 sine t, 6 times minus 59 over 100, minus 177 over 50.